Hey there, welcome back to my channel. Let's continue with our series. In the previous episode, we have integrated our payment gateway implementation, and we have collected our payment also with the help of the Stripe UI, where user have entered the card information and we have collected payment successfully. Right after that, the user Stripe is also able to call the place order endpoint, right? In this episode, we are going to work on the remaining part of the things, which is order create event using SNS and SQS. So right after successful payment, user service will be publish some kind of the SNS topic, right? And our transaction service is going to consume that specific SNS topic with the help of SQS, where we are going to perform these two operations, where create order and the create transaction log. Once we successfully verify that the transaction service is able to create the order and create the transaction log, then we will move to apply the clean architecture in transaction service, where we will learn how this layered architecture is working and what is the benefit of the implementation of the clean architecture. That is we're going to do. So let's deep dive into the source code. Here in the transaction service, let's try to understand what are the changes we did for our infrastructure. First of all, in the transaction service tag, as you can see here, let me close this window from here. So here in the transaction service tag, you can see this is our order queue we have created, right? Which is going to subscribe to a kind of SNS topic, which has already been created from our topic errand, where in the user service, we have already created this, this topic, right? The SNS topic. So here we are just getting the reference from there. And this is the subscription of that SQS, because if you can see here in this diagram, right? The SQS is exactly subscribing to SNS topic. So this part exactly happening right here. So this one. And after that, we are just getting out all the Lambda functions from the service tag, right? So we have pretty much the 4 Lambda functions, which is called the create order, get orders, and get transaction. So here in the create order Lambda function, we are adding a kind of event source. So which event source we are adding? That event source is a kind of order queue. So that means here create order Lambda function exactly it's subscribing to that SQS queue with the help of the SNS topic, right? That is the part exactly we are doing right here in this portion, right? So finally, we are exposing our API gateway stack here. So where we are exposing all these functions, all right? So this function we should not supposed to expose, but I just kept it just for testing purpose only. Later stage, we can just omit from here as well as. Perfect. So let's have a look at our service tag, right? Click on the service tag. Here you can see on the top of this service tag file, we have imported a couple of things that is exactly it's needed, right? And our service props, this is a kind of interface which is being used right here. So that is, we are just keeping empty. Maybe in future we can add your resources here as well as whatever the props or maybe environment variable, we can pass it from here. From here you can utilize that. So these are our Lambda functions. And you can see this time we have created a Lambda function a little bit different way, right? So here we have mentioned only Lambda handler names, right? So why we are just keeping the Lambda functions individual way? Because in the previous episode, I have already explained to keep the Lambda function leaner and smaller along with the dependencies. So the size can be optimized and it can be very quickly or easily it can be deployed, right? That is the benefit exactly, right? So if you go to the source code and click on the handlers, you can see these are a bunch of Lambda functions we have, create order and the get orders and get transaction, and all the Lambda functions are exported here in this index.ts file. So at least we can directly refer to that index.ts file and we can get all the Lambda functions from here. So what we can do here, if you go to service tag, then only one function gonna be take care of here. While we are creating the Lambda function handlers, you just need to pass the handler name, right? The file will be remaining same. So this is the way we are just segregating and calling all the functions, right? Now let's go to the API gateway stack. And API gateway stack, you can see these are again the same similar pattern exactly we have followed, just like we did for our product the service. And this is exactly the resource type, which is also we have applied. And right now you can see the add resource here in this specific function, where we have created our API gateway, right? So this is API gateway is created here, and after that, this is our order endpoint, and this is our transaction endpoint. So we are not adding that the create order function right here as a kind of API gateway. We are not exposing that, right? Only we are exposing three functions that is called get order, get orders, and get transaction. So get orders will give you the whole bunch of order, and get order will give you only one single order by user ID, and get transaction will give you all the transactions. Maybe we can add one more Lambda function, which is going to give you only specific function or specific transaction by ID, right? But for a while, these are the minimum things. Exactly, it will be fine. And you can see here in the order resources, right? Here we have created two functions that is called the create endpoint and create add child endpoint. So create endpoint is pretty much similar, just like earlier we did, right? So where we are creating our Lambda integration with the help of the handler, which is a kind of I function, and we are adding the resources here, and how many numbers of the items we have passed right here depends on that. We are just adding resource. Once that resource has been added, then we are returning these resources here. And the add child endpoint function is taking a couple of parameters that is called path, right? So which path exactly we are adding it to our child resources, and what type of method exactly, method type it is, we need to mention here. So that specific method type will go here. And the handler exactly that, because you can see in earlier we have one single Lambda function can handle everything, but this time we have individual Lambda functions for each and every child as well as, right? That means while you are creating the root endpoint, then you can use this function, and while you are adding the child endpoint, then you can add this function, right? So here it is taking all these parameters, all right? And this resource is exactly this one, you can pass it on, right? And finally, what we are doing, we are based on these resources, we're adding the add resource to path, right? And after that, this specific child resource can have like add method function, where we are putting as a kind of method, as a kind of type, post, get, delete, whatever it is, and that specific Lambda function is going to take care of that specific method, right? Based on this specific path. Let's check it out, the implementation. Here you can see in the order endpoint where we are creating here, while we are creating the endpoint, we are passing the get orders Lambda function and API gateway, right? The REST API gateway, this one. And then it is returning the resources, right? If you go here, you can see this is returning the root resources, right? Based on this root resources, exactly, we are just passing it right here in the add child endpoint. So it can be created the sub endpoint just like this. This is our the root endpoint, right? The orders, where we will get all the orders, and after that, this endpoint exactly adding the another endpoint order of that specific ID, which is maybe called just like this order ID, and it will give you only one single order. The similar way we have created for transaction also. And if you want that like on specific single transaction need to create, then this is to go ahead and implement this way. These are the two functions exactly helping us to create the nested endpoints. All right, so now let's go to the source code, right? I'm gonna close everything here. Close all. Save. First of all, let's check it out one by one. So this is our DTO directory where we have just created our input, right? And this is our order item, and this is our transaction input, and this is the main input of creating the order. So as soon as we are receiving the SQS message, then it has to be parsed and it has to be filtered out in a JSON way, right? So we are using the class validator in order to capture the errors and everything. So we have used like this way. So it can have items where we are having the order items, and it can have a kind of transaction input, which is we are providing the transaction stuff from our user service, and it can have a user ID. So this whole input, it can be found here in the user service. If you go to user service here and go to app and handlers, click on here, this one, the order handler, and click on the place order. So here you can see in the place order function, as soon as we are receiving the request here, we are checking it out whether it is authorized or not, right? If it's a kind of authorized user, then get the user profile, all right? Find the payment ID, right? If payment IDs exist, then retrieve the payment information. And if the payment has been succeeded, all right, then find all the card items. Then just to construct a kind of SNS topic, all right? with the help of the message, where we are putting it our user ID is a kind of current user ID, and items of our card items, and payment transaction is our payment info, which is maybe successful or whatever it is. So, but in this case, we are only considering if there is a kind of successful payment, then only we are sending this SNS topic, right? Then we are only publishing. So here we are just constructing our SNS and we are publishing this SNS topic here, right? So this is the exact structure we are just to try to follow here, because we are not border at all this topic error and message attribute and this message attributes exactly makes sense, because based on this specific action type exactly listening to our queue, right? So in our case, we are using placeholder. Maybe in another way, if you wish to publish something else, then make sure like your action type has to be matched with your while you are subscribing something from there. So in our case, if you can go to this transaction service, go to leave and transaction service tag, here you can see the action type, the subscription filter exactly the placeholder, right? This has to match. All right, so and now it is pretty clear. The user service, whatever exactly is publishing, this is a kind of user ID, items, and transaction, right? The similar thing we have handled here as an input, which is called raw order input, items, transaction, and user ID. So the items exactly is going to be order items. This is, you can find it out here, product order ID, product ID, name, price, item quantity, and image URL, and created ad. So this order ID doesn't make sense, but still we can just keep it for further uses. The transaction can give you a lot of information, but only the meaningful information is going to be needed for us. That is called the payment ID and amount. This is exactly the requested amount and how much money you have received. That is the amount here. And this is the capture method. Capture method can be automatic or maybe manual or maybe something else, right? You can check it out in the Stripe documentation. And this is the created timestamp exactly. This is currency, customer, payment method, payment type, and status. So this is the extremely valuable the variable where it will become like based on this status, we are going to create the order, right? So these are the things exactly happening right here. And this is another input that is called create order input, which is being used in our database level. So that's why we have just created this one. Okay. And now let's go to handlers. So in the index.ts file, we have just exported all the handler functions, right? Transaction, get transaction, create order, and get order. All these three handler functions we have just exported here. So let's go one by one. So here, when you click on the get transaction, this is exactly nothing. So this is the DB operation file, which is we have created here. This is only the connecting with the DB, right? So let's try to omit all the stuff. Okay. And maybe we can just get rid of this try catch as well as that's not required. Perfect. So this is our DB operation file. And if you go to DB client, similar kind of stuff, which is we have implemented in our user service as well as. We are simply creating a kind of PG client and we are returning here, right? So I just kept this log just for check it out whether it is getting connected or not, or the credential I'm just using, this is the same or not. So definitely this is going to be something else, all right? So we are going to create a kind of another DB. This is the way we have created for our user service. That is, we are going to do a little quick. But for a while, I'm just going to explain like what the client it is and how the things can be worked, right? So this is our DB client, right? Let's try to close this one. And DB operation is getting called this one while we are executing query. It is first creating the client and connecting the client, and it is performing the query. And after that, it is ending the client. So just to make sure, like while you are using in AWS and Lambda, then you should have supposed to end the client every time whenever you are doing, because you cannot reuse the connection here, right? Maybe other way using the pool connection pool, you can reuse it, but this is the efficient way to just make sure once your work has been done, then make sure the connection has been closed, right? So now this is the DB operation class. Let's close it out. And here you can see in the get transaction, we are doing nothing. We are just like querying the stuff like select star from the transaction, limit 500, right? So we are getting all the transaction data. Once this result has been successfully executed, then we are just finding it out and we are returning back to the client. Hey, this is the transaction data, all right? And if this is not happening, then we're saying like, sorry, we didn't find your transaction. So, oops, this is transactions not found. Okay, so this is the error message, right? So this is the get transaction Lambda handler, and now let's go to the get orders. And here you can see this is the get order function. The similar way we have just imported our DB operation file here, and we are doing a query here, and we're just to try to find out all the orders, because this is the get orders handler. Just to keep in mind, this is plural and this is singular, right? And here we will be get only one single order. So here we can do much more stuff, but my agenda is to consume the SNS topic with the help of SQS and create the order, right? So here I'm just performing a simple join and to find it out all the orders and the order items by finding the user ID, right? And user ID, we are just passing a kind of path parameter. Maybe later stage we can implement the auth service as well as that in order to finding out the authenticated user. But just for demonstration purpose, like ID is perfectly fine. And once this is done, this result is getting back, then we are returning it. Otherwise, we are returning some kind of error, right? So let's go to the create order function, which is a kind of pretty much big Lambda function, but we will work on that in the later stage. Okay. So first of all, let's try to understand what is going on here, right? So create order handler Lambda function is taking care of like the consuming the event from our SQS. So as soon as it is getting fired, then it is receiving kind of event, right? The event can have records, and each record can have the messages, right? All the messages we are just consuming here. If you can see here in SQS event, right? You can have it can have a record, and record can have SQS record. SQS record can have a message ID, a recipient handler, this body attributes, and everything is here, right? So we are interested on the here in this body, right? Which is we are being used right here. You can see we are going to have a kind of map function. And here we have used the map function to go through all the records, right? And each record can have a body, so which is we have parsed here, right? And we are using the class transformer, right? And finally we are getting it all the inputs. If there is some kind of error, then it will be throw you right here, right? So you can see, let's try to collapse this one. You can see if there is some kind of error, then it will be pushed to the order response error, and it will be printed out here as well as it will return the response, right? Let's try to understand what is going on here. So first of all, you can see this order response exactly. It's a kind of record, which is a kind of string and unknown. So this is we are keeping it just for our reference. So at least at any point you can go to CloudWatch and check it out whether our message has been processed successfully or not, just to check it out. Okay. And this record, event records can have multiple records, right? So this promise exactly, it will be confirmed. All the message has to be processed first. Then only we will say our process has been finished. The Lambda function is over. Otherwise, if you are not putting this in place, right, like this, then what is going to be happen inside whatever the process is going to be happen, it will not going to be executed properly. By adding this one, right, by adding this promise exactly, it'll await unless all the processes has been finished from here. All the operation, whatever the related operations exactly we are executing here inside this the map function. So first of all, we are just parsing our JSON stuff here, and we are converting to our class, so at least we can reuse the whole stuff, and we are finding it out, evaluating the error. If any errors are arising, then report it here. Otherwise, if there is no any error, deconstruct all the transaction stuff here, and now create a kind of transaction query here, right, which is inserting the transaction. These are the attributes we are adding here, and these are the values. And finally, we are executed the specific query, transaction query, right, where all the query and values has been added, and if it is successfully executed, then we are finding out the transaction ID. So where you can find it out, this transaction result row 0 and ID, right? So if the transaction result is not successful, then we are doing nothing, then it is going back here, right? Then once this is successful, then we are creating our order reference number by performing this operation, right? So it will be generate a kind of order reference number, which is going to be very, very helpful to find the order by order number, right? We no need to rely on the serial number, which is generated by our SQL. And we have added a kind of status that is called received, because every time whenever you are placing an order, it has to be flag is a kind of received or something is a default status has to be there. Then depends on that status, we can proceed further. As an example, once we have received the order, then we need to proceed to out for delivery, or maybe shipped or something, whatever exactly, we can just put it on, right? So this is the query where we are inserting the orders. So again, this similar kind of SQL query we are doing: order, user ID, and status, amount, transaction ID, and order reference ID, right? So these are the values exactly. And once we are performing this order, right, then order result has been, it will become over here. Then we are finding out the order ID, because the order can have the items as well as, right, order items. So that is, we need to keep track. So if you can see here in this diagram, in database section, yeah, you can see this is now our shopping cart, the cart items, all right. This shopping cart can have the cart items. So these are the cart items exactly. While we are placing the order, exactly this, it is sending from our SNS topic, right, as a kind of message. And while we are consuming this one through SQS, then we need to keep safe the specific order items from here. So we cannot directly keep the reference here in order cart item, right? And again, order need to call our another microservice to, hey, give me all these items. We cannot say that, right? So this is exactly temporary. We are saving it while the card has not been checked out. Once this card has been checked out, then we are moving all these things with the help of the SNS topic to our transaction service. So transaction service is creating the transaction first, then it is creating the order, right, where ID, user ID, status, and amount, because this orders belongs to some user, and this order can have a transaction, right? That transaction also can have enticed with this order ID, right? Then this order can have the order items, right? So those order items, exactly where exactly it's coming from, it is coming from here with the help of our SNS SQS and SNS topic, right? Now this order item we need to create right after created the order. So that is what we are doing right here. You can see once this order has been created, then we are just to try to create the order items, and it's a bunch of items. It can have maybe more than one items, so that's why we are keeping as a kind of map here. And this is not a good practice, like performing all the operations in a kind of async way inside the map. So what we did, we just keep a kind of promise here, item insert promise, right? It's a kind of array, and we are inserting everything. We are pushing all this executed query inside this specific array. And finally, once all the items, order items, its iteration go through, then finally we are executing this one, this promise as a kind of promise all, the item insert promise, right? So this execution is happening, and this is inserting all the items in once. Cool. So this is the thing exactly happening with the help of the SNS and SQS, the subscription. And finally, you can see once this is done, then it is saying like all the process has been taken place. Now it's good to go. So this is the thing we are doing right here. Okay. So let's give it a try. So what we can do. Anyway, so first thing first, we need to spin the whole source code in our AWS account. So let's close all the files first. So what we need to do, first of all, we need to create one database. That is, we are going to create just like we did for our user service, right? So if you go here, this is my instance exactly, it's running right now, right? And you click on the connect, right? I'm going to connect this one. Let's go here. Right, yes. Yeah, it is connected now. Now let's log into a PostgreSQL. Right, then PSQL. Right, now let's try to create a kind of a rule here. Transaction service. Yes, rule has been created. Let's try to check it out whether we have the rule it's listed or not. We can see we have the listed the rule, but it says they cannot log in. So we need to provide the login capability. Let's try to provide the login capability. Alter rule transaction service with login. Yes, and we need to provide a kind of password as well as. So let's do the same thing. Alter rule with password, and we're going to keep the same kind of password. Okay, perfect. So let's try to list it out once again. Right, so now our transaction service has been created, but one more permission is going to be needed, that is called the create DB. So let's try to provide that as well as with create DB. Create DB. Now our transaction service is ready for connection, and it can have the capability of the create DB as well. Right, so I'm going to close this one, and let's try to go ahead here and click on the public DNS. All right, and we are going to use the table plus. So I'm going to create one more connection that is going to be PostgreSQL. Let's try to use this one. So, service hostname this 5432, and username will be transaction service. Transaction service hash 2023, and database name going to be Postgres. Yeah, connection is successful. Click on the connect. Then we are inside the table, right? So we are inside the database. So let's create a database. So here we can create a kind of new database that is called transaction service. Perfect. So now this is our transaction service database. Let's try to connect with our application, right? So in that case, let's copy this DNS once again and go to the source code. Yeah, cool. So here inside the transaction service, we have created a couple of migrations, right? This is the same migration settings we did for our user service. You can see like this similar kind of stuff we are doing right here, right? And for local development also, we have created the Docker Compose file. So this is the Docker Compose file we have just created here inside the transaction service as well as. So at least while we are running on our local machine, we can have a separate database for sure. So in that case, we have selected different port for this transaction service. For user service, we have 5432, right? So here, this is our database .json file which is going to help us to run our migration. So let's try to change the credential a little quick. So this is going to be our credential, right? So production, that's not required for a while. Let's try to make this way. And yeah, and this is our user ID, which is called transaction service. And this is our password, transaction service. And this is not user service, this is going to be transaction service. Yeah, right, that's cool. Now our database.json file is set. Let's try to copy this URL from here, copy. And we're going to utilize the same thing here inside the source and utilities, right? Utils inside the database client. So here also we are going to use the same. All right, so this is not going to be user service anymore. This is going to be our transaction service. Perfect. And now let's check it out. What are the files are inside this migrations directory? So migrations directory, we have only one file that is called init table. If you can see init table up, we have created our couple of the tables here in the SQL, right after generated this migration file. So this is our transaction table where ID is primary key, amount received, right, capture method. So rest of all the parameters we are just adding accordingly, right? So here there is no any kind of the foreign key because this transaction doesn't belongs to anything, right? But one thing is needed, that is exactly from order side, because while we are having these specific transaction, exactly it's related to order only, right? So that's why in order table we have a kind of foreign key that is called transaction ID, and you can see transaction ID exactly we are just keeping reference from the transaction, this one, right? So right after created this order table, we are just keeping this reference as a kind of foreign key, right? And in this case, we are creating a kind of index as well as which is called order ID, order reference ID, because at any point while we are looking for orders, then we should supposed to able to source all the orders by order number, right? So order reference number. And after that, we have created order items. So in this case, order item is going to be similar, just like we have created the card item in our user service. Only difference is here, this order ID. This order ID, again, we are just keeping as a kind of foreign key, refer to our order table by this ID, right? So this is pretty cool. Like we have 3 tables: transaction table, order table, and order items table, right? And finally, we are in the down file, which is called init table down. Here, first of all, we are just removing our constant first, if it is exist. Then we are just deleting, and because as you know, like if you are adding all the constants, then you should supposed to remove the dependencies table first, then the second one, and then the third one, which is we don't have any dependencies, right? So order item we are just removing first, but right before we are just removing this order item, order ID foreign key, right? So let's try to execute the migration, right? All right, so now let's try to spin our migrations. And right before spin the migration, go to table plus and check it out whether we have any data right here or not. Into transaction service, yes, we don't have any tables, right? That's a good sign. So let's try to execute this migration. I'm going to keep it in position bottom. Right, so this is not required. Maybe we can delete this one. Okay, kill terminal. Okay, this is fine. Now make migrate. So go to the migration file, make file. Yeah, migrate, db migrate app environment as a kind of div, because if you can see in this database JSON, so this is the exact parameter environment we have added. All right, so if we have a kind of production, then make sure like you have a kind of production block. Inside the production block, you can add all the required credential for production. And now we are going to do the same thing here, migrate, db make migrate. Yeah, perfect. So our migration is taken place successfully, right? So it ran without any error. So let's go ahead and check it out in the table plus. Refresh. You can see we have all the tables, right? Perfect. Now what we are going to do, we are going to deploy our transaction service, right? Close all the files. Now cdk deploy. So it's gonna take a couple of minutes maybe. So once this is deployed, then I'll get back to you. Perfect. So our transaction service is deployed successfully. So let's go to the AWS account, and here in the CloudWatch, we're going to clean all the logs. So it seems like there's no any kind of new logs, right? Perfect. So this is a good sign. So what we are going to do right now, this transaction logs, this is the exact URL which is we are going to use in our front end, right? So if you go to front end, this is our front end directory. Inside the front end, there is a source. Click on the API, and inside the API, we have this product API, and here this Pine order items API, this is the transaction URL exactly. Go here, and we are going to place this specific URL with the new one. Right. So this is our transaction URL. So now one thing is there, like once we are going to run this application, we should supposed to collect the amount, and as soon as we are collecting amount, it has to place the order. And once order is placed successfully, then our SQS it has to take a kind of action by subscribing that specific SNS topic, and it has to create the order and transaction bot. Right. So let's go ahead and give it a try. So I'm gonna run this application, switch back to our front end. Start. So we're going to log in. Yeah, so successfully signed in, and now go to the cart, and yeah, this is the cart item. So which is supposed to tackle it in the front end while we are requesting this call, so some kind of loader rather than showing kind of empty data here. So now in the CloudWatch, do we have any kind of logs? Yes, so let's try to clear it out all. We're not interested to see all these logs for a while, but once we are placing the order, right? Yeah, the card is loading, right? Then we are going to put the expiry date, CVV, and pay with Stripe, right? Order is processing. Yeah, order has been placed. So if you go to the CloudWatch event, you can see like the place order is getting called, and right after place order is getting called, then you can see this is the Lambda function which is fired from our SQS event, right? By subscribing the SNS topic, then we should supposed to see some kind of log here. So this is the latest call, right? And click here. Yeah, error is false. This is our event. Yeah, response. Yeah, everything is clear, I believe. Yeah, cool. So let's go ahead and check it out whether we have some data here. So if we refresh this transaction data, can you see the transaction has been, it's added here, but I don't know why. Maybe twice we have added this one, so we need to handle it. Let's try to figure out why we have duplicate orders, right? If you go to user service here inside the app and handlers, and go to order handlers here, and this function place order, this function is responsible to create the orders, right? So somehow it is getting called twice, right? It may be called twice or maybe multiple times due to the client issues, or maybe client is getting refreshed or something like while calling this specific on the HTTP call, right? Now how we can handle it? So let's try to understand this scenario. Here in the place order function, we are not accepting any kind of the payload from our client, right? This is not a good practice. Push a lot of, like maybe a bunch of the payload to place the order, right? Just try to keep it minimum. In our case, we are just try to minimize the whole thing in terms of like we are only interested in this token, right? Which is exactly, we can get it from headers, right? And right after this token, we are just trying to get it out whether the user has a kind of successful payment or not, right? And this payment exactly we can find it by this payment ID, which is already we have saved while we have initiated the payment, right? On the time of the collect payment, then we are just creating the payment session. Then here we are getting the payment ID, which is already been updated in our user profile. So that means every time whenever user try to initiate a payment, the payment ID will be get updated, right? And now this place order function has a kind of responsibility. Once this specific order has been fired successfully, all right, publish this message, make sure that specific payment ID has to be maybe empty here, right? So here, maybe we can put it right here. Payment ID equal to empty, right? And here also one more thing we need to do, that is called this card items. So because the order has been placed, right? And this card items, it doesn't make sense in our user profile. So make sure it is deleted here as well as items, right? So these are the two things we need to tackle it in our user service, right? So let's not try to cover it in this episode, because this episode exactly dedicated to our transaction service only. We will be working on that while we will be working on our deals and our buyer section, right, of the user service. Then we will just cover it out. So let's try to handle in our transaction service, right? So here in the create order handler, every time it will receive a message, right, it will going to create a kind of new transaction. It doesn't matter whether this payment ID is similar or not. So in order to prevent that specific issue, what we can do, we can make this specific payment ID is a kind of unique constraint, right? So that means while it will going to create the first time, then it will create successfully, and second time while it will going to try to create the stuff, then it will definitely gonna throw kind of error, right? If this is a kind of error, then definitely inside all the operations, like it will not create the order item, etc. Right, so let's try to make it. Let's go to user service. Maybe here you can see in the migration section, here inside the migration and SQLs, here in the user, maybe somewhere we have used that one, and that is called, it's nothing exactly, it's unique. You need to set it not null, right? That is the way. So I just want to show you how we did that one. in the initialize up, you can see this is C, email, unique, not null, right? So this is the piece of code which is we need to add in our SQL, right? Let's try to close this user service, go to transaction service and migrations, and inside the SQLs here in the init table up, anyway, we are going to drop this one first. And here in the payment ID, let's try to add this one. In order to execute this one, let's get into our transaction service. Cd transaction service, make migrate. First of all, make migrate down, right? Then make migrate, yeah, perfect. So our migration taken place. So if you go to table plus, then if you can see in the transactions, go to structure. Now you should supposed to see there are two unique constants. One is the primary key, right? This is unique true. Second is like this one, right? Column name is payment ID. Okay, so this time now we can just give it a try from there, but let's try to make sure this has been deployed correctly. Perfect, so it is deployed correctly. Now let's get back to front end. Cd back. So then you can start. Okay, let's go to CloudWatch. Let's see if any kind of logs are there. So try to delete all those logs from here. Delete. Okay. Now sign in. Yes. Go to card. Yeah. This is our card item. Place order. Yeah. Let's try to add the card number. Right. Okay, pay with Stripe. Perfect, so our order has been placed successfully. So let's go here and try to refresh it. Okay, so far, yeah, now the SQS is executed successfully. Let's try to get into here. So if you go here and the first place, it is taken place, see, this is a response, and second time it is just giving a kind of error. It is saying kind of invocation error and duplicate the key violation unique constraint payment ID. Yeah, that's perfectly fine. So this error will be not giving us once we taken care of the user service, all right? Right after deletion of the card items, then definitely it will be not come up. But for safer side, in the transaction side also, transaction service also, we need to take care this way. So that's why we just added this one. Okay. Now I think we are good to go. And if we see here in the table plus, right? Go to table plus and transaction, refresh. Can you see right now only one transaction item here? And if you go to order items here, right? Orders, then only one item we have, one order we have. And the order item is similar. It can have a multiple, but as of now we have only one order item. That's why only one item is showing here. So let's go to the front end as well as let's check it out whether we have the proper things are here or not. Go here in the guest and click on the orders, right? Can you see only one item we have? So this is all exactly, right? So front end side, we can do much more stuff. That definitely we can do that. But from the backend aspect, right now it seems like our core logic for the complete the customer journey from buy the product, right? And add to cart and place the order, and right after place the order, consume that specific event from our SQS queue, right? And then just to create the order, create the transaction, and create the order item. Everything has been covered. In the next episode, we are going to apply the clean architecture in our transaction service. Already we have been following the layered architecture, but this time we are going to do a little bit different way, so it can give you kind of more understanding why or what is the beauty of the clean architecture and what are the things it can be make you easy, like in terms of on the plug and play of your data adapter or data source. At any point you can just change your data structure or data source, right, without touching your business domain. So those are the things we are going to cover. All right, I hope you like this video tutorial. If you really like this video tutorial, give me a thumbs up and go to my GitHub repository. If you find some kind of useful repository right there, don't forget to put a star right there as well as. And if you have not subscribed to my channel, subscribe it right now, because there are a lot useful tutorials. I'm gonna put it one by one. So yeah, see you in another episode. Thank you.